Hi. Today I want to talk about nil slices versus empty slices. You probably have heard about this oddity of the Go language. If not, then stay with me and I'll explain it to you here. So here we have a little Go playground script, and let's run it again. And I have one empty slice, an empty string slice, and a nil string slice, because if I just define the variable, as you probably know, that's of course per default nil. Now, if you print these two, you get exactly the same output. Also, if you take the length of these two, you get 0 in both cases. So you cannot distinguish them in that respect. But as you probably know, if you try to append to a nil slice, it's going to crash. So you better make sure that you compare the slice with nil. That's the only comparison you can make with this slice. And if you have an empty slice, this comparison will be false. If you have a nil slice, it will be true. So that's how you distinguish. As you can see here, reflect type of still gives you the same type, of course, string. That's because, of course, here the variable is of type string slice. So nil is a bit special in Go in that it is typed, but you cannot really see that. And sometimes the type behavior is relevant and sometimes it isn't. So that's maybe one of the design mistakes of Go. To be fair, Go is not really my preferred programming language or my favorite programming language. It's just the best choice for my projects at this time. But there are many of these little oddities in Go that make it problematic if you don't know them. But if you know them, it's no problem. Now, in this case, this was, of course, not the problem. Everybody knows that. And if I go to my data layer, I have some validation and I'm very meticulous about it. I make sure that all my slices are basically empty slices, so they are all initialized. So I can use the structs without having to care about nil here, and I can be sure that I can append to the slice. So here, if I have, for instance, a groups, which is a string slice, if this is nil, then my arc struct will not validate. And that's the way I dealt with it, and there was no problem with that. That way, you get a little bit of a performance cost because you have to initialize all the empty slices, but that's a low price to take for some ominous crashes when you forget about a nil slice and then try to append to it, right? So that worked well until I used protocol buffers, because that's the odd thing. If I go to my protocol buffer definitions, now that's not it. Here, the protocol buffer definition for an arc has repeated string users here and repeated string groups, right? Now, the odd thing about protocol buffers and how they were designed is that if you put an empty slice into the protocol buffer, it's going to be a nil slice if you take it out of the protocol buffer. That is crazy. So it's an optimization that it doesn't want to transmit this over the wire, and so the empty slice is turned into a nil slice. And of course, I wasn't aware of that. It's certainly somewhere in the docs. But if you use this, you wouldn't expect an empty slice to become a nil slice. So that basically means that protocol buffers do not guarantee that what you put into the protocol buffer is what you get out of it. And that was new to me. So what you have to do in your conversion functions, you can see I put the slice in, and this is guaranteed to be an empty slice, not nil. And when you get it out, here I have the accessor function, get users. This is going to be nil if it's an empty slice. So I have to check for it, make the string slice, the empty string slice, and then put the empty string slice into it. You have to do that for every conversion of any kind of slice. And that's just important to know and to be aware of. I think it's a horrible design decision. No matter what you think about the way Go deals with that in general, the protocol buffer should be designed in a way that what you put into it is also what you get out of it. And it shouldn't just, null some value that was something else before. I think this is just a bad design decision. In any case, you should be aware of it. This led to a bug, of course, and it led to multiple failures. In my case, it was just a validation failure, no crashes. But still, of course, it's a very ominous thing, and it took me quite a while to track this problem down and then add all these clauses in the conversion function to ensure that my nil slices are turned into empty slices. So if you fall into this pitfall, hopefully now you've seen the video and this can't happen to you. And it seems like a not so great design decision. It's clear why they made it. They want to save over-the-wire space, and it's also more performant. But yeah, you need to keep it in mind. So that's it for today. See you next time. Bye.